Hey guys, welcome to week 2 of trigonometry. So last week we talked all about right triangle trig. This week we're going to talk about law of sines and law of cosines. We're going to do 2 days of law of sines, 1 day of law of cosines, and then 1 day where everything's combined. Your homework again will be due Sunday at midnight, and it covers all of law of sines and law of cosines and solving for the entire triangle. So let's get started. So law of sines and law of cosines is how you can find the side measurement and angle measurements of a non-right triangle. So we use right triangle trig with all right triangles, but what do we do if we don't have a right triangle? Because a lot of triangles aren't right. Well, we use law of sines. So law of sines is any triangle, A, B, and C. So just so we know that angles are designated by capital letters and sides are designated by lowercase letters. So if I'm looking at this triangle here, here's angle A, and across from angle A is going to be side A. Okay? Always across from it. Here's angle B, and across from angle B is going to be side B. And the same is true. Here's angle C, across from angle C is going to be side C. So those are always across from each other are going to be the capital letter for angle and lowercase letter for the side, no matter what the triangle is named. So what is law of sines? Well, law of sines is sine A over side A equals sine of angle B over side B equals sine of angle C over side C. Sometimes you'll see that flipped where the sides are on top and the angles are on bottom. Perfectly fine as long as the sine is going with the angle measurements and all of them are flipped. So when do you use law of sines? Well, you can use law of sines any triangle if you know the measurement of two angles and a side and the measure of two sides and an angle opposite one of them. So what I always think when I'm doing law of sines is I have to have a pair. Okay? I have to have one angle and one side with same letter. So if I don't have one angle and one side with the same letter, then I can't use law of sines yet, okay? So what that means, I have angle A and side A, or angle B and side B, or angle C and side C. I have to have something in common in order to use law of sines, because if I don't have anything in common, then I'm not going to be able to solve these, okay? So let's get started. I know you did law of sines in geometry, but let's see what we recall from here. So we're going to do example 1, and they're given that angle C is 100, angle B is 53, and side B is 9. So what I always suggest you do, and I'm sure your geometry teachers do the same, is I always suggest you draw the triangle. Now a lot of the times my triangle is not drawn to scale. Just be aware. I usually just draw the same triangle, but I'll try to do better here. So this is going to be angle C. So it's going to be side C. And let's say this is going to be B here. So this is 53. And so this is going to be side B over here, which is 9. And this is going to be angle A, and this is going to be side A. Well, what do I know? Well, it says to solve. So when it's saying to solve, it wants to know every angle and every side of the triangle. So they want to know the measurement of angle A, the measurement of angle B, and the measurement of angle C. Well, we know C is 100. We know B is 53. And it's quite easy to find A, right? Because the measurement of a triangle is always 180. So we do 180 minus 100 minus 53. And 180 minus 100 minus 53 gives me 27. So without having to do any law of sines, I know that measurement of angle A is 27. And we're good. We're still going to round angle measurements to the nearest whole number and side lengths to the nearest tenth, unless the directions say different. So now we have all our angles. So let's talk about our side. I need to know side A, side B, and I need to find side C. And the only thing they gave me was side B. And I can't use Pythagorean theorem here because I don't have a right triangle. So now I need to use law of sines. And the only pair that I have there is I have B. And you get to pick what side do you want to solve for. I suggest to always solve for the largest angle side first. So largest angle side first. That's going to get you not into this ambiguous case. It's kind of like this black hole. So I'm going to decide for side C first. So I'm going to go over here, and here we go. So I have sine of 100 over C equals sine of 53 over 9. Because these are proportional, what I can do is I can just cross multiply them. So I end up with 9 times sine of 100 equals C times sine of 53. I'm trying to get C by itself, so what I'm going to do there is divide by sine 53. I really think one of the hardest things in doing this is that people type it in their calculator wrong. So just make sure you type in your calculator right. So I get C equals 9 times sine of 100 over sine of 53. So what's C? Again, we're going to round C measurement to the nearest tenth. So when I'm typing this in the calculator, what I like to do is I like to do the numerator first, then divide by the denominator. So I like to do 9 times sine 100. Make sure your calculator is in degrees, not radians. Enter. Divide by sine 53. And I get 11.0980. So we're going to do 11.1. So C is going to be approximately 11.1. And that makes sense because the largest side length should be across from the largest angle measurement. So the largest side length should be across from the largest angle measurement. If it's not, there's something wrong there. Okay? So now I have C. Normally I would go back and say, okay, let me just do Pythagorean theorem here to find A. But I can't do that. I have to use law of sines again. But it's the same process. I like to stay with what I'm given. So I was given this is my B right there. So I like to constantly use this right here as my go-to fraction for everything. So I'm going to find A now. So I got sine of 53 over 9 equals, remember we found side A, and side A was 27. So we get sine of 27 over A. So again, I'm going to cross multiply. I'm going to do the exact same process I did. You guys will get really, really good at kind of the process here because you just do it over and over again. It's very repetitive in law of sines when you're just finding both angle measurements. So I cross multiply. I'm now going to divide by sine of 53. Okay. These are going to cancel. And then what I'm left with is A equals 9 times sine 27 over sine 53. And so I figure that out. Again, when I enter that in my calculator, I'm going to do 9 times sine 27, enter, divide by sine 53, and I end up with 5.1. It's 5.116, but again, we're rounding it to the nearest tenth. So 5.1. And if I go back up here, I have solved for my entire triangle. Okay? Example 2 is the exact same way. What I suggest you do is that you try example 2. If you have any questions or things aren't adding up, definitely log on to Zoom and ask me questions. Tomorrow we'll do law of sines day 2. We'll be doing that when we're finding an angle measurement first instead of finding a side measurement first. Have a great day. If you have any questions, log on to Zoom or email me. Thanks, guys.